to the first tutorial in the beginning bioinformatics section of the course. The first thing you'll want to do is to go to Canvas, and if you look in the modules section, you should find this beginning bioinformatics part 1 .docx and download that to your local machine. I mean, you can view it online, but I think you'll find it easier to manipulate and use the links if you download it so that you have a local copy. You can also mark it up that way in case you want to take notes. So once you've done that, slide over here. And I'm just going to try to make things as big as I can. Essentially what we're going to do is walk through this document. So I talked about this a little bit on Thursday when we were going through the syllabus. I rambled on a little bit at the end about why I like teaching this class and some of the good things you can get out of it. But I'll talk about a few of those things in a little bit more detail. Why do we do Unix and Linux? And then we'll get into really doing some introductory Unix things, learning to navigate from the command line. That's what today is all about, really. Learning how to make your terminal useful in terms of creating and manipulating files. All right. So I guess I should also say we'll get into when we get into that first doing the Unix part. Yeah, if you haven't already if you're on a Windows machine and you haven't already gotten the Windows subsystem for Linux running, you won't be able to get very far. But I'll come back to that in a second. So you know, like all introductory courses, that first section there, you know, what is bioinformatics? You'll have a hard time finding consensus about what that really means. I come from a background of genome evolution, evolutionary and population genetics. So mostly when I teach bioinformatics, it's going to be a course about DNA sequence analysis. The whole learning to program thing, it is a valuable skill generally today, and especially as I mentioned this on Thursday, it becomes easier and easier to collect lots and lots of genome or transcriptome scale data. The person who learns to code pretty quickly becomes the sort of go-to person in a lab because they're the only ones that can deal with the kind of amount of data that is coming in. Now, this class is probably not going to turn you into a programmer. That's not really my goal, but it will. So I think I have a quote. Got ahead of myself a little bit. Maybe I took it out. One of my grad students, you know, at the end of the course, one of my former grad students said he didn't know if he had become a better programmer, but he had definitely become a better Googler. And so at least this will introduce you to the language of programming. And along with that, constant practice is important. Just like if any of you have learned a foreign language, there is no substitute for actually doing it and doing it on a consistent basis. So as you're doing these tutorials, I encourage you to sort of revisit them. You will get homework problems that make you sort of use your skills synthetically over time. But if you do all the homework on Monday and then don't look at programming or any of the bioinformatics stuff for a week, you will lose it as fast as you gain it. And so I encourage you to sort of revisit it a little bit every day, because that will help you just develop a more synthetic working understanding of how to, the syntax and the words of the language will just become more second nature. I think this is another important thing to consider, and one of the reasons that I really like this course, and one of the things I learned as I became a quote-unquote programmer, is that the skills that you learn when you're having to write and debug code really do help you become a better scientist, because they make you break down problems into their component parts in order to troubleshoot them. It's similar to if you've ever had to troubleshoot a PCR, breaking down all the components that go into the reaction and figuring out, okay, which one is not working. That is a similar skill. It just happens maybe more acutely or a little more quickly in programming, because you're able to make changes a little faster than you can in a PCR reaction, right? It is the same problem in that if you have code that doesn't work, the computer doesn't do anything. If you have PCR reagents that are bad, or a thermal cycling reaction that is inappropriate for your primers, for example, you just get nothing. You don't get bands, or the PCR doesn't work. And so you have to tear apart those problems, try to fix them one at a time. And part of this course will be teaching you how to do that in the programming context. I showed this graphic last Thursday, but some of the pragmatic reasons for why would you want to learn, your biologist, why would you want to learn how to program? Okay, this is, like I was saying before, when you're talking about one gene or a small amount of data, at some point, the person who just brute forces it in Excel or whatever the sort of hands-on software may seem like they're making more progress, while the person who's writing code isn't making a lot of headway on solving the problem until the code runs, and then it doesn't matter how big the problem is, right? You can just feed it into the code, and it will do the analysis. Some of the long-term reasons, postdoc ads, right? If you're a PhD student thinking about staying in academia, lots of the high proportion of postdoc ads explicitly require programming or bioinformatics experience. Evildur, that is a listserv for evolutionary genetics and ecology and evolutionary biology job listserv. If you've never heard of it and you're a PhD student, let me know, or you can Google it, but it's a nice listserv to be on because job ads are posted there constantly. These are projected job openings, right, from U.S. Bureau of Labor Statistics. Computer occupations are the fastest growing. Probably doesn't surprise anyone. Way faster than sort of the category of life and physical sciences, for example. So more specifically than why learn to program, why are we going to use Unix and Linux? Because it's basically the universal operating system for scientific computing. When we go to use the remote resources in the Exceed, which you'll learn what that's all about. Anyway, the remote cloud computing resources all run Unix operating systems, so that's what we're going to learn to use. That doesn't mean that you have to run a Linux machine locally. That doesn't have to be your everyday computer. For a long time, I sort of forced everyone to use the same Linux environment. We went through a whole hassle in the first week of class of getting a virtual machine on everyone's personal computer that could run Linux. But a few years ago, Windows decided to put a subsystem for Linux in Windows 10. And so now Windows users can run Linux somewhat natively on their own machines, and Mac OS is already basically a Linux variant. There are some technical differences, but for all intents and purposes, the terminal on a Mac machine runs just like a Linux terminal. All the commands, you can run the same commands. And then once you activate Windows Subsystem for Linux, you will be able to do that on Windows machine as well. These are the same links that I provided on the syllabus, so nothing new here. And like I said a few minutes ago, if you don't have that active, you won't be able to get very far in a few minutes when we start actually doing some of the tutorial. Just a few words here about it may seem like a technological step backwards to do things from the command line. And I'm going to show you a little bit about how you can go back and forth, especially on your local machine, between sort of this, this is the Mac Finder. Depending on how you want to look at these, right? It may seem like a step backwards to go to this and have to navigate from the command line, but when you go to the supercomputing resources and work remotely, there's some overhead that comes with having to pipe a graphical interface back and forth over that thing that is really unnecessary, and so hasn't been developed very well. And so it's just easier to learn to, it may not seem like it up front, but it is easier in the long run at this point to just learn to manage from the command line. And there's also a lot of very powerful things you can do from the command line that are, well, I wouldn't even know how to do them from the sort of graphic interface of a standard file manager. Why Python? I'll leave this mostly for you to read through. There are a lot of good reasons for using Python. It is the most rapidly growing and by some measures the most popular coding language today, partly because it really is useful in all areas of programming. From app development on desktops to mobile devices, back-end programs that have browser interfaces. It's a very readable language. That might be the #1 reason that it's gained so much popularity so rapidly. This graph down here from last February, when I first started teaching bioinformatics, I taught it in Perl. Maybe some of you have never even heard of Perl at this point. It's kind of so shocking how rapidly Perl fell out of favor. It wasn't a very readable language, not an object-oriented language. That was really its major limitation. I mean, there were some hacks to get it to be able to write modules, but you can see Python has grown every year. Everything kind of died off in 2021. There just weren't. This is number of jobs on Indeed.com. There are lots of metrics you might use. This is just a big job board, so it's generally reflective. Now you might notice if you're an R fan, R is not listed in here, and I'm not sure why that is. R is especially popular in bioinformatics. It's more of it is a statistics-oriented language. It has lots of packages to do statistical analysis built in. but it wasn't broken down by Coding Dojo. So I don't know exactly where it would fall in here. It is popular in bioinformatics, but I'll also say, because there is some debate about whether it'd be more useful to learn Python or R. In our biology grad program, you will learn R in the stats classes to some extent. We also, from time to time, have something called software carpentry workshops where they will focus on R. And in the big picture, anything you can do in R, you can also do in Python. It's just a matter of getting the right packages installed on your machine. And to some extent, the same is true. Most of the things you could do in Python, you could also do in R. They just tend to be a little more clunky in R. One of the things that you'll find if you stay in bioinformatics long enough, everybody has their own favorites. So if you learn and become expert in R, you will think everything's easier to do in R. I am way more familiar with Python. I think everything's easier to do in Python, except for some plotting. So we may do some plotting in R. All right, that's it for intro. So let's actually get started doing some fun stuff. First thing, find a terminal. And I have mine pinned to my dock here, but and unfortunately I don't have a PC where I can show this really quick to you. So, but the videos that I had linked, right? They show you how to get your Ubuntu terminal up and running. If you're on Mac, you know, you can just go to Launchpad and type in terminal, right? And that will get you the terminal app. So mine does not look like that because I have a couple things installed. So you don't need to do this on yours because you don't have the little thing that says base there. And that is a package manager that's preloaded every time my terminal opens up. And you can just ignore that for now. Just going to blow this up a little bit. Okay. So I just cleared my screen. So when you open up a terminal, it should look something like this. And it's the same format as you're seeing in the beginning Bioinformatics Part 1 guide. Okay. This screenshot is from when I was running a Linux version. This is what it looks like on my Mac. Your colors may be different. I've modified the colors of my terminal, and how you do that is different on each platform. If you're on Windows, it won't be the same, but yeah. So if you're on a Mac, you can do terminal preferences, and you'll get all kinds of different ways that you can make the colors look. But the text is the important part, and it's showing my username and then the machine that I'm on. So this Prometheus is the name of my laptop. And then inside the brackets, that tilde, whoops, I don't know what happened there, is the shortcut name for my home directory. And we'll see in a few minutes what that looks like. Now I could make that, and on a Linux system, it may give your username as the home directory, but these are effectively the same thing. This is just a shortcut, shorthand version of saying that I'm in my home directory. whatever directory I'm currently in is called the working directory. In a few minutes, we'll see how do you find the whole path to that. But for now, just keep that in mind, that whatever's in the brackets, that's the directory we're currently in, and it's called the working directory. Also say, I am not going to read word for word all of the stuff in here. There's a lot of detail that I've put in here. Some, especially if you look at the blue boxes, I've given a variety of tips, and then I'll also point out some of the things I haven't read along the way. Just the more time you can spend doing this and playing with it, the more little things you'll find. Some of them super useful. That comes second nature, and I won't remember to even say them all the time, but to the extent that I can, I've gone back and included these every time I think, oh, that would be useful for them to know. Things like this. I remember when I first switched from PC to Mac, getting over the difference between the control key and the command key. Control is not the same as command. And when you're in a Linux environment, you're usually going to want to use the control key, not the command key. Okay. Because I'm on a Mac, whenever that becomes relevant, I can point that out. If you're on a PC, this is one of the cases where PC is actually easier, because you don't even hardly ever you don't have an equivalent to the command key on Mac. You're used to using control. Like, you know, the key shortcuts on that Control C to copy and Control V to paste, if you're familiar with those. Right, on a Mac, it's Command C and Command V, but all of that gets messed up when you move over to the terminal, because you want to use Control, not Command, most of the time. All right, so second topic, how to list files. So how do I look at which files are in my directory? I just do ls for list. And yours will look different than this. It just depends what files are in your home directory. Okay. So there are quite a few in mine. This is the example that's specific to if you were running some a variant of Linux called Bioinformatics, but it will just depend on what's in your home directory right now. If you don't, if you type ls and nothing comes back except the command prompt, so you can see after it finished down here at the bottom, right? It listed everything that was in my home directory, and then it gave me the command prompt back. If it didn't list anything and it just gave you the command prompt back, that means it doesn't mean it didn't work. It means there's no files in that directory. This last thing, the ls command can be used to list the contents of any directory, not just the one I'm in, right? So when I just type ls, it's going to print the contents of the working directory, right? So I'm in my home directory, it's going to print that. But I could say print some other directory. Well, actually, let's just keep going and we'll see how to specify those. So how do you find the path? Like, what else? Like, if I wanted to list the contents of some other directory, how would I specify that other directory? The way to think about paths, okay, I think lots of people know you're used to thinking about things like this. So in this case, the styles folder is inside my EndNote folder. Okay, if I go up here to my Adobe folder, I've got these folders inside. So the directory structure is hierarchical. Things are nested inside other directories. If you're on a Linux machine, this is the default directory structure. I don't think anybody listed Linux as their directory on the Excel file from our first day. So for those of you who are on Mac, the very highest level, and this is true for all of them, the very highest level is called the root. Okay, and if you just specify this /, that's specifying the root. Okay, with underneath the root on a Mac OS, you have applications, a library system, folder called users, and then bin. Your home directory, or my home directory, the JPDamith or the shorthand name is just tilde, is underneath that users. Okay, so over here on the left, sort of tried to put those things in words, right? So if I wanted to get to my downloads folder, I would start out at the root, that /, then I go into the users directory, then /, and then the username, which in my case, JPDamith, and then another / to go into downloads. So if I wanted to list the contents of my downloads folder, oops, I would do something like this: ls/users JPDamith. Oops. Downloads. Okay, and so I hit enter there, and actually I have a lot of stuff in my downloads folder. Okay, but then after it finished listing everything, it gave me my prompt back. Now, if you're on a Windows machine, it gets a little trickier, because when you start your Ubuntu Linux terminal, you're sort of running in a different home directory than your Windows home directory. The Windows subsystem for Linux is really its own subsystem. So right now, if I were on Windows and I did / and then lowercase h home, and then / my username, that would give me my Linux home directory. But your home directory for Windows, like when you log into Windows and you see your desktop, that desktop is in your that would be like this desktop folder. Okay, so you're in on your Windows home directory, the C drive, and then users, and then JPDamith, and then the desktop is what you would be seeing. Okay, so if you're at the command prompt on a Windows machine and you do ls and you get nothing, it just gives you the command prompt back. It's probably because in this home directory for Linux, you don't have any files in there yet. Okay. And the reason I'm highlighting that is because you might think, well, my home directory actually has a whole bunch of stuff on my Windows machine. But that's your Windows home directory. Okay. So I just showed how to do the downloads folder for ls users JPDamith downloads. That will work on a Mac. That if you were on a native Linux machine, it would be this command right here, right? That one. So slightly different. Instead of having users, they have home with a lowercase h. If you're on Windows and you want to know the downloads folder for Linux, right, you would do /home, your username, and then downloads. But if you want to do the downloads for your, like when you download something from your browser on a Windows machine, it's going to go into this downloads folder. Whoops. Right, that's your Windows downloads folder. So you will have to do this path right here. Because when you start up Linux, this terminal is want to start from here when you specify a path. So you have to start with that slash, and MNT stands for mount, and it's the hard drive is mounted. The C drive is mounted there. So you have slash mount slash C slash capital U users, and then your username, and then downloads. One of the fun things you can do when you have a graphic interface and the terminal side by side. So in Mac, I can do stuff like that and drag from Finder onto here, and it automatically fills in that path for me. I think that also works on Windows, but I'm not sure. So that can be a quick way, especially if you have something that's really buried on your computer and you're not exactly sure how to specify the path this way because it's so many layers deep, right? If, for example, all right, here's my Mac desktop folder. Right, there's my home folder on my Mac. If I want to go to that desktop folder or list the contents, I can do ls and drag it over there. See, it's the same as what I typed in a minute ago. Okay. Same thing. I could do that for downloads. Okay. And it went really fast, but so that was listing the contents of my downloads folder and then giving me the command prompt back. To help sort out that issue for Windows users, I put this little detour in here. So if you're a Mac user or native Linux machine, you can ignore this. This is just for the Windows subsystem for Linux. If you're on a Windows 10 machine, I've given you instructions here, little 8-step thing to tell you how to change the default directory from that Linux to your Windows home. I'm going to just caution you to be careful. Type these exactly the way they're written, right? Because there are some commands I'm using here like sudo nano. Sudo is giving you super user privileges. Nano is the built-in text editor. When you use nano, right, the command nano is going to open this text editor, and you can't use the mouse in there. Okay, so you can only use the arrow keys to navigate around. But this is not something that you need to do. It's just kind of handy because it makes all the things that you're using your Windows part of your computer to download and things. It puts them in just so where you intuitively expect them to be, not in the Linux home directory. Okay, because if you go to Canvas, for example, so I go to Canvas and then I click this to download it, it's going to put it in this downloads folder. But if you're in your Linux terminal, to get to that downloads folder, you have to specify this whole long path. Okay. So it's something that's kind of handy, but not necessary. And it's one of the things that during class time, I can help work on that when we're in person. Okay, so, and also something to keep in mind for the rest of the tutorials, if you're on the Windows machine, right, there may be some differences in what you see, whether you're in this home directory or that home directory. All right, so next thing, so we've listed directories. Next thing is, okay, how do we change directories to actually go someplace else? We'll change the working directory. Okay, so the task here is to change directories into our downloads directory. So from my home directory, I can type cd downloads. And we'll talk about that slash on the end and whether that's necessary or not. Okay, you don't really need it. Okay, so I did cd downloads, and see how now it's changed. Now inside the brackets, it's no longer the tilde, it says downloads, because my working directory has changed. Now if I do ls, okay, again, listing the contents of my downloads folder. And the text here corresponds with that screenshot. Stuff in my downloads folder has changed over time. Again, Windows users, if you don't see anything there, it's probably because you're in a different downloads folder. So, especially if you're kind of lost at this point on a Windows machine, how can you figure out where in the world you are in the directory structure? That is the print working directory command. So just do pwd, print working directory, and the output will give you the path to your working directory. So I'm in my downloads folder. That is /, right? That's the root because the path is starting with a slash. Users, username, downloads. Little pro tip here. Not necessarily one of my top 10 pro tips. We'll get to the #1 pro tip in a minute. But whether you're on Windows or Mac, sometimes it's useful to actually go from the terminal to the GUI, the File Explorer or Finder. And so from a Mac, I can just do open space period. And the dot here means the current directory, the working directory. Oh, it opened it on the other screen. So anyway, it opened this window when I did that command. If you do, if you're on a Windows machine, you do explorer.exe space dot. It will open whatever that current working directory is. It will open it up in File Explorer. Okay. Next up, we're going to U6 and U7 are going to be about the absolute versus the relative path. So far, I've only been talking about the absolute path. Whenever the line starts with that slash, it's referring to the absolute path because it's starting at the root. The absolute path is it's good from no matter where you are. Like I can be in my downloads folder and specify someplace, like do cd to anywhere on my computer from here. I'm just going to cheat and Right, whoops, there shouldn't be 2 slashes there. Right, I'm in my downloads folder, but I'm specifying the absolute path to this file over here. I don't even know where that is. And it doesn't matter because when I dragged it in here, it filled in the absolute path from the root. So all the way down through the file structure to wherever that file was that I wanted to get to. And just as a way to show what the difference is here, like if I do cd usr, right, there is no directory called usr in my downloads folder. But if I do this, actually, is this cd/usr, now it changed my working directory to usr. Okay, now if I did pwd, where do you think it's going to tell me I am? Okay, it should be exactly that absolute path that I just gave it, right? /usr. So if I scroll back up here, think about what we just did. That means it's not even shown on the Mac OS picture here. I probably should, tell you there is a file here called USR. Now I have shown it on the Linux cartoon directory. So I'm actually in the /usr folder. Mac, so that's my fault. I should modify this picture so it's not confusing. But there is a USR folder right underneath the root in that first level on Mac systems, just like there is for regular Linux systems. And it should also work on Windows, right? There is also a USR folder in that first level on Windows subsystem for Linux. It is a default Linux directory. Okay. Now, the relative path is relative. It's called relative because it's always relative to where your current working directory is. So I'm going to go to, let's go back. So how could I get home? cd users jpdaemon. Okay. So notice it now is giving me that tilde. And that is the shorthand for my home directory again. So pwd, right? That's where I am. Now, if I want to go up one level in the directory, I use 2 dots. So if I do cd ... I went up one directory from home into the users directory. So let's just do ls to see what else is there. You can see there's my home directory, there's a shared directory, and then there's a guest directory within the users folder. You can also use the double dots to go up more than one. So let me go down here. So I'm going to do cd all the way down to my downloads folder. Okay. And now I could do cd ... That would go up 2 levels. And where do you expect this to land us? It should land us back in users, right? Because it's going to go up from downloads into jpdaemon and then up from jpdaemon into users. So if I hit enter, indeed, we ended up in users. And as you're going through these, it's always good, and especially if you get tired of listening to me and decide to just go through the Word document. It's always useful to ask yourself these little questions about what am I doing? You should be able to interpret what you're typing, not just copy what's on the document. Okay. The way you learn cool new stuff is often when you get unexpected results, and it could be that you made a typo, or it could be that you found some new kind of shortcut. Especially when you want to make short moves between things, using the relative path is often easier. That's the whole point of the sort of shorthand. Whoops, I want to change that. For example, another way for me to specify my downloads, right? I've told you multiple times now that tilde is the shorthand for my home directory. So no matter where I am in the directory structure, if I start with a tilde, that is going to put me in the jpdaemon directory. Okay. And then type downloads. And so from wherever I would have been, I was in the users, so I went home and then downloads. So now I'm in my downloads directory. I guess in here I use documents. It's the same thing. If I want to move from my downloads folder to my documents folder, I guess that's what this U8 is showing you, right? I know to go from downloads to documents, I need to go up one into my home directory and then down one into the documents folder. Okay. So that can save you some time rather than having to specify the complete path, right? So that's what this is showing. I went up one and over to documents rather than having to specify the absolute path from the root users jpdaemon documents. Okay. In this case, it's not saving you a lot of typing, but as you know, we would be deeper into a directory with our data and maybe one of our analyses. You know, we could be 5 layers deep, and we want to only move over one directory. The relative path can save us a lot of time that way. It also, especially on the remote computers, may be hard to know what the complete path is all the way from the root. And we'll experience that later. You'll just have to take my word for it at this point. If you just do CD, okay, shortcut, that takes you home. So just 4 things to try there. Right, if I do CD that's not going to take me home. That's going to take me to the root. Okay, so that's all the way at the top directory. If I do ls, you can see, right, these look familiar, right? There's my users, just like the cartoon I had in the document, except there's a few that I left out, right? There's the user one that I didn't have in the cartoon version in the Word document, but it's there. And we saw CD tilde will take me home. Okay, that next one, CD /, that would go to the root again, but then it's just showing that if you just do CD and then nothing, you end up back at home again. Okay. Okay, so just showing you that's the shorthand for your home directory. Okay, so now the best Unix tip, and this is something that you should commit yourself to learning as soon as possible. Use tab complete. So even though you can't see the keystrokes that I'm using, some of you may wonder, or think, man, he typed that fast, right? So I do CD. The second half of that finishes out and puts a slash at the end really fast because I'm hitting tab. So as soon as I do DOW, capital DOW tab, and it fills in the rest. So that's what I mean by tab complete. It doesn't only work for directory structure, it also works for command. So in this case, I typed TO tab, and then nothing came up because there are multiple commands that start with TO. If I do TOU, it fills in touch, and that's a command we're going to use in a minute. Okay, but that tab complete is so useful. It's especially useful for navigating because you not only do you not have to worry about typos, but if tab complete doesn't work, that means the directory doesn't exist in the path where you're trying to type it. So right now, let's see. I'm going to use Finder here just to give an example. Okay, so if I do CD DE tab, so I hit tab and it filled in desktop, then I can do, let's do, right, oh, that's not it. So that's the associate chair directory. That's kind of messy just because of the way it deals with spaces. Let's go to the Beatles one, okay? So I did BE tab and it filled in Beatles for that directory. Now, if, let's just pretend I forgot that I'm not in my desktop directory, I'm actually in my home. So if I try to do CD BE tab, right? I don't know if you can hear that little dong, the music, the sound it makes when there's an error on mine. So I'm hitting tab and it's telling me that it can't fill it in, right? So if tab complete's not working, that means the file that I think I'm trying to navigate into doesn't exist where I'm trying to tell it to go, right? And then I think, well, that's weird. That /be, oh no, it's not under the root. So that would be a situation where, you know, I don't know where I am. So I do pwd. Oh, I'm in my home directory. So I need to go desktop. There we go. So the tab complete helps me figure out the path because it will only work if the directories exist in the place where I think they do along the path. Yeah, I cannot emphasize enough how useful and how much time that will save you. It's hard to appreciate how useful that is until you have banged your head against the wrong path for a long time, or enough times. So I just give you some hints for, you know, trying to practice using those. You saw this with the touch one already, but if I just do DO, it doesn't fill in anything, but it tells me there are two things that start with DO, documents and downloads. So I need to give it another letter before it can finish the tab complete. So if I give it a C, then it fills in documents. If I just did D, this should give me desktop downloads and documents as options. Oh, and well, I have one called data and one called Dropbox that start with D that are all in my home folder. Okay. So then you just add letters and hit tab, keep hitting tab until it fills in what you want. Okay. Super useful. Okay, I mentioned this a few minutes ago. You know, when do you need to slash? Essentially, the trailing slash doesn't matter. These two commands, ls tilde documents, and then the same thing with a slash at the end, will give you the same output. The only benefit of that trailing slash, and you'll notice whenever you do the tab complete, it automatically hits that trailing slash, because it just saves you time if you want to specify another subdirectory. That command and this command, whoops. So with and without, they did the same thing. It's just a tiny time saver. Okay, and I talk about, especially if you've got a really long path, having that slash there does save you some time. Number 12, the history. Okay, if I type history, I will see the history of commands that I've used. Okay. This is where we started today. Those are from other work. So it does keep a continuous history. I'm actually not sure when or how it decides to reset. Right, because this is saying 489. I started today's history on number 489. You can play around with these, right? If you want to see just, say, the last 5, you can do that. If you know what it was recent, okay. That's interesting. I don't know what happened here. That might be something that changed when the, so looks like I'm running bash. It doesn't matter. That the history 5, right? It listed my last 5 history, or the last 5 commands that I ran. If you want to run a specific command, you start it with the exclamation point and then the command number. So if I do exclamation point 530, it's going to do cd desktop. Actually, I'm already in desktop. This will probably fail, right? Yeah, no such file or directory. Why? Because I'm in desktop and I ran the command cd desktop. That tries to go into a desktop folder when I'm already in my desktop. So I'm going to go cd to get home and then run, whoops, exclamation point 530. Okay, and now this time it worked. Now, it's a little silly to need to run history when they're short commands like that, but you can see, like, you know, if you go back up here farther in my history, there are some long commands. You would not want to type that thing out again. Okay. If something went wrong and you needed to rerun that command, rather than retyping the whole thing, I could just do exclamation point 473 and it would re-execute that command. Even better than that, if you know it's really recent, you can hit the up arrow. And this is something that, after the tab complete, that's the best pro tip I have for you. The second best is use your up arrow. If something doesn't work, you just got done typing out a big long command, right? Don't retype the whole thing and risk just making a different typo. Instead, hit the up arrow and then move over and correct your typo. Just fix that part. Okay. So all I'm doing right now, you can see it cycling through commands. All I'm doing is hitting the up arrow. Now I can hit the down arrow and run back through them the other way. Okay. So tab complete and up and down arrows to cycle through your history of commands. Super useful. The two best tips for learning to navigate in Unix. And that up and down arrow thing, that carries over to lots of remote computing kinds of things. If you want to run the previous command again, for example. So this last tip here about Control R is a search through your history. And if you're on a Mac, remember it is Control, not Command. So if I do Command R, it doesn't work. Okay, so I just typed C, and it went back through my history and looked up the first command that started with a C. Okay, now I did. Okay. Skip that. Now let's Control R again, and that would be really helpful. So I typed SCP, and you can see that stands for secure copy. We'll learn about that later, but this is one where I knew there was going to be a long command associated with it. And let's say it had just been a long time since I had to use SCP, but I knew that a couple of weeks ago I was having to copy things from the computer in my lab to my desktop. And so that command must be in my history. So I can just do Control R SCP, and I don't have to remember the syntax or the file directory for where the RNA-seq data was. It just automatically brings up that command for me. So, another really useful one, especially if you've had to use some complex commands and you know they should be in your history. All right, a little bit more useful use of list. So ls-l. I'm going to go to my home directory first. So that's ls-l. And you can see rather than just listing the files and directories, I get more information. So this first group is the object type. So if it says D, that means it's a directory. If it's a dash, usually it's a file. And then there are three sets of 3 characters. Let's see if there's one that's completely filled in. Well, so this one up here is almost completely filled in. The 3 characters are RWX. They stand for read, write, execute. And it's read, write, execute for the owner, for the group, for the individual. Or owner, group, and other. And that's basically specifying who can do what. So the owner of the file, in most cases has read, write, execute permission, or just read and write permission in some cases, if it's not an executable file, for example, or I haven't made it executable, which we'll talk about down the road, why that's important. And then, you know, for often the group or others will not have write access. That means they can't overwrite the file, they can't delete the file, things like that. The number of links, we don't have to worry about that in most cases. Yeah, it's not something that we need to worry about. And then it's who is the owner. So in this case, me, the group. So this is where you can specify usernames that belong to like administrators of the computer. It's a way to give group permission. So everybody in your lab, for example, you would want to have write access. That would give you the capability to do that. And we'll talk about how you deal with permissions as we go along later in the semester, a couple weeks from now. Okay, and then you get to this column. How big is the file? Okay, in bytes. And then how long ago was it modified, or when was the last time it was modified, and then the name of the file. Now, depending on the computer and the color scheme that you're using, or not the computer, the operating system, whether on Windows, it may look different than it does on Mac. Ubuntu has some default colors. I think these might be Ubuntu default colors. But anyway, the coloration, mine, you can see it's not coloring the directories a different color than the files. Yours may be doing that by default. I don't have that active. A couple other things that I'll just let you experiment with on your own here, but just ways to get additional information from the list command. ls-l is the most common, but there's another one, ls-a, and you see all these files that have dots in front of them. Those are all hidden by default. The -a means all. If I do ls-la, now, whoops, needs to be a space. Now I should get that list that has all the information, and I should be able to see all of these hidden files. So things like configuration files are often hidden. And I'll bring that back up if we need to use it later to modify some of those hidden files. Okay. Some stuff here about when you need to separate these dashes. So this ls-l-t-r. And then here I just do ls-lh. Okay. I could do, you know, you can play with this on your own, but for example, in the example there I do -l-t-l, but it is the same as doing -ltr. Okay. There are a bunch of options that you can use with the ls command. I don't, ls-l and ls-la are the two that I use the most often. And I'm sure that you will also not need to know all of those, but just know that they're there. And if you ever want to know what are all the options, you can use the manual pages. Okay. So here I did ls, or I did man space ls to get all the options. You can see there are loads of them. Well, this reminds me, Linux, almost everything we do in Linux is case sensitive. So if you see a capital letter, it has to be capital. If you try to change directories, whoops, Q to use the letter Q to get out of the man pages. Oh, there's the quote from Nick finally. Right. Yeah, I remember. I stuck it down here now because those man pages are often not super intuitively written, and so you may be better off just Googling sometimes. For example, Linux ls and options. I think that's all right. Next thing we're going to do is make a directory. So mkdir. Oh, actually, you know what? Let's make sure we're in our documents folder first. So from wherever you are, navigate to your documents folder. Actually, I created a, yeah. So if you're following closely, you know that I'm in a documents folder inside my documents folder. And I did that just so I would have this tutorial stuff separate from, because my documents folder has a lot of stuff in it, and I wanted to keep this tutorial clean. So if I do ls now, right, there's nothing. I'm in a blank documents folder. If you want to, you're welcome to do that too. It doesn't really matter that I'm doing this in documents. I'm only doing it to keep it consistent with what's in the Word document here. Try and reduce some of the confusion at least. So in that documents folder, I'm going to make a directory called tutorial using the mkdir command. So that's make directory. And name it tutorial with a capital T. And notice it didn't give me any confirmation, didn't do anything, just gave me the command prompt back. Okay. Now, if I do ls, indeed, I have a directory there called tutorial. Now I'm going to do make directory temp1. I'm going to cd into te, and then I'm going to hit tab. So now right, that tells me that I was successful at creating that directory because the tab completed it for me. Now I'm going to make another directory, make directory temp2. And then I'll cd to temp2. And now if I do pwd, you can see, like I was saying, I have a documents folder inside my documents folder, but then I created temp1 and then I created temp2. And I am all the way down in that second temp2, the second folder. Okay. And I can also see on my working directory in my command prompt, it says I'm in temp2. Just providing a note here. That was the step-by-step way to do it. We could have done all of that in one command using the -p to create those nested folders. Okay. So this task, you should be able to, with the stuff that you've learned so far, from anywhere on the directory structure, right? Like go home and then try to go directly to temp2 using the absolute path from the root. Okay. And we just printed the working directory when we were in temp2, so that right there is your absolute path. So to move there, you would go CD, and then you would have to do that path. But you won't remember this. Use tab complete. Capital U tab, J tab, DOC tab, DOC tab. Temp1, temp2, bam, all the way there. Okay. And then I'll let you do the second one on your own. But it's basically using the relative path from your home directory. So instead of starting from the root, right, start with a tilde instead of your username, and then the rest of the path to get there. Okay, U16, how do we get rid of these directories that we just created? I'm going to go to, whoops, documents. Okay, remember mine's a little different than what it says because I have 2 layers of documents. Okay, so from the temp1 directory, I'm going to do remove directory temp2. Okay, no confirmation, pretty dangerous. But I guess the slim comfort here is that if there were any files there, it would have given us an error because remove directory only works on empty directories. Okay, so I'm going to CD up one more level. Whoops, that's not what I wanted. There we go. Let's do CD up. So now I have temp1 and tutorial. Move temp1. Move tutorial. Okay. It didn't give me any errors. So now if I do ls, okay, there's nothing there. So that was 16.1. Now, touch, which I hinted at earlier when I was doing the example for tab complete on commands. Okay, touch. I'm going to create heaven and earth files. Oops. Touch heaven, touch earth, list. Okay, now I have 2 empty text files. And that's all touch does. It just creates a file, a blank file. And I don't have to name it .txt. I could name it anything, and it will just create a blank file with that name. Now, MV moves files. So I need to move this over and make a little room. First thing we need to do in this is make a directory. Oops. Okay, so I have temp. And now if I do ls, I have the temp directory. Actually, let's do ls-l. And you can see how temp is a directory, earth and heaven are files. So we do move heaven.text to temp. Right? So again, always stop and think about what you're doing. I'm using move the heaven.txt file. That's the source, I mean the target. Right, we're moving this source file, heaven. This is weird. I think I have. I should probably say from the source to the target, because we're gonna move something into something else. We're gonna move this heaven file into the temp directory. Now, if I do ls-l, the only thing left here is my temp directory, right there. And if I go into temp and do ls, now I have earth and heaven. So I've moved them from this documents folder, right, where I had temp, earth, and heaven all together. I moved them into the temp directory, and so now earth and heaven are inside that temp directory. And just in case you want to see what's going on, this might be useful if you're not really sort of intuitively following what's going on from the command line. You can also go into your Finder or Windows Explorer and look. So this is my documents folder. This is the documents inside the documents folder that I created. I was telling you, so I got to keep everything for the tutorial in a separate place. Okay, and then there's the temp directory that I created over here. And inside of that, right, there's my heaven and earth files. Okay. So if it helps to think about it in this way, you know, you can follow along with making those files and making the changes inside your Finder or File Explorer. This is an example. I can move these out. This isn't the example that's on there because I've already moved them into my temp folder. But now from inside the temp folder, if I want to move these back up one directory, say move the star.txt, this asterisk is going to work as a wildcard. So it's going to get any characters and then .txt. And I'm going to move them up one file. So I'm going to, or up one level. So if I just put ... there, right? If you remember a couple of the modules ago, right? That is the relative path to go up one directory. So now, if I bring my Finder back, see what happened. Now temp is empty because it moved those two files in there. Now, right, show you what happens here in real time. Okay, I'm going to do this exactly like it shows. MV asterisk.txt. Oh, I have to go up one. So I was hitting tab complete thinking, all right, I wanted to move them into temp. So I was hitting TE tab and it was giving me an error. So, but that's because I'm in the temp folder. I need to CD up one. Right, this is where everything is. So move the text files, asterisk text to temp. Okay, and if you look at this, right, when I hit enter, you'll see them move. Bam, right? Okay. All right, next, in this temp folder, keep doing that. I'm in documents, I want to CD into temp. And create 3 files. Okay, notice this time I didn't use the .text, and if you want to see what happened, right, I've got now those files and I created fat feet. Okay. This is just kind of showing you how you can use introducing a couple of wildcard characters like I did with the asterisk there that recognizes anything. And all of these are just to introduce you to some shortcuts that are useful sometimes. Right. So that question mark matched any one character. I add another question mark. So what I just did there is I hit the up arrow. So right, I had a blank command line, hit the up arrow, and the up arrow did that. And then I'm just adding another question mark. And what's the expectation here? It should list feet. Okay. And this may not seem, why is that so useful? Well, if you have a directory that has, 1,000, 10,000 files, read files, and you want to find some specific subset, that's when those kind of knowing those little shortcuts to specify a wildcard at one position can be really useful, because you want all of the read ones that match a certain pattern where I want things that start with this 4-letter code and then any 2 numbers, and that could be one example where something like that would be useful to pull those reads out. So the move command, we're still we used it in U18 to move a given file from one to another, but when you want to rename something, you also use the move command. And so it's really just like moving the file to a new name. So, for example, this says touch rags, which creates the rags file. I should just leave this up. Right, so now that created rags. And I created that in the temp file, so I'm just going to do mv rags riches. Now, you know what? let's do this. Let's move it up one. So what's this going to do? It's going to move the file that we just made, rags, so that's this thing, up one directory, and it's going to rename it riches. Because Unix is smart, it's not going to, it recognizes riches is not the name of a directory. And so when it moves rags, it's going to make it a file called riches. So that's the same as renaming something, right? So it took rags out of this directory, moved it up one, and saved it as riches. Okay. Well, I'll let you try that one on your own, but hopefully you're starting to get the hang of it to where you can look at this and tell what it's going to do. Now, it's still good, especially in terms of remembering things, to actually type it, because there's some kinesthetic learning that happens there in actually having to type it and make it happen. But also thinking about, okay, this lists it. Okay, if I'm in the right directory, temp, okay, it doesn't follow with what I've done up here. All right, I would have to be in this documents folder to get that riches one. But listing it says there's a riches in that folder. Now, move riches space rags. What is that going to do? Well, should just rename it, but leave it in the same directory. So it should change the name from riches to rags. So if I went up one, there's riches, move riches, right, whoop, riches. Should have used tab complete. Okay. So, right, change that file from riches to rags. Okay. You can use that move command to move things anywhere. You don't even have to be in the location. I can move that temp folder. I'm going to go. This is one where it's a little confusing because of the way I did two documents folders. But if I go up one, okay, and then I do move inside that other document, so that's the second level down, documents, temp, whoops. Huh. Okay. You should be able to literally follow what's in the thing, but because of the way I did this two documents folder before I started recording today, my path is not the same because my second level documents, I have to go back up one more before I can move over to desktop. And I don't know if you heard the error, right? The way I know that is when I started typing, just trying to follow along right here, and I hit DE tab, I get an error. It tells me something's wrong with my path. Oh yeah, I forgot my, regretting having made that second documents folder now. But if I go up one and then do DE tab, there it is, desktop. Okay, so now I moved that temp folder that we had onto my desktop. So if I go here, let's find my desktop, and there it is. Got moved up over to my desktop. All right. close to the end here. The most dangerous command you will ever learn, the rm command. So I said earlier that when we used the remove directory command, there was some safeguard because the directory had to be empty, but rm does not require that. Right. So read this section very carefully. Just don't just listen to me. Okay. Maybe not needless death and destruction, but it can really mess you over if you use rm command and you're on a machine that doesn't ask you for double checking. Lots of Linux systems, when you try to use rm, it will say, it will warn you that you're about to delete files. And there's no recycle bin like modern Mac and Windows. If you use rm and you confirm it, that file is gone. And especially when you're using this -r command, which stands for recursive, that's how you get rid of whole directories and everything in them. Okay? There's no recovering if you accidentally do that. So be very careful with the rm command. So, right, read this. Potentially very dangerous. Let me repeat it again. It's possible to delete every file you have ever created with the rm command. Are you scared yet? You should be. Okay. I have had people in this class rm some system files that totally crash their computer. So be careful. If you follow the instructions, you shouldn't have any problems, right? The tutorial. And if you understand what you're removing, right? Don't, like, it is a very dangerous thing to use wildcards like that asterisk that I was talking about with the rm command. Okay, that's how the accident happened with the guy's system files. The task here is to remove the temp directory and all of its contents, which we now know is on my desktop. My desktop. So if I cd to the desktop, do ls dash, well, let's just do ls. So there's the temp directory. I am going to rm. I don't actually remember the difference between capital R and lowercase r. In the tutorial right here, I have lowercase r. I'm not sure it matters. We'll see. So rm-r temp should get rid of that temp directory. Now see, on my Mac, I have it set up where it doesn't warn me, doesn't ask me if I'm sure I want to delete that. That temp directory and all those files that we created in there are now gone. Just to show you, right, that my desktop, no more temp directory. I think on Ubuntu you should get that warning. I'm just going to try something here because I'm curious about the capital R lower. Actually, check man rm. If you're not sure, look at the man page. Oh, it's equivalent. So capital R tells you all about the recursiveness. Right. Recursive just means it's going to go into all the directories and the subdirectories. It will work its way down and delete everything. Okay, so lowercase r is equivalent to capital R. It's not always the case that capital and lowercase are equivalent. Whoops. And then again, to get out of the manual page, I just hit Q. Sorry, I was just looking back at the move command. The pattern is the same in copy and move. I don't know why I got those backwards on the move. It doesn't matter too much as long as you remember it's whatever you're moving and then wherever you're moving it to, whatever you're copying it to. Copy is just a CP command. So here we're first creating a couple files to work on. So we touch to create file 1. I don't want to do this on my desktop. Actually, let's move that file. Move file 1 to documents. Okay. Okay, so I have file 1 and rags left here. Now let's copy file 1. Copy file 1. And then the second thing is I'm copying this to this. So in this case, I'm just going to create a copy and name it file 2. Now I have file 1, 2, and rags. I'm going to get rid of rags. rm rags. Let's file 1, file 2. Okay. Now, a lot of things I'm obviously doing here are not in the tutorial, but hopefully, what part of the reason that you've got the tutorial and I'm walking through this is so you're also seeing the utility of some of the commands as they come up in sort of real life situations, right? And you should be able to being able to track what I'm doing. Maybe not always easy to understand why, mostly because the peculiarities of how my system is set up. But okay, file 1 and file 2. The second section is just an example where we can make a copy and create things in other places and copy them to and from places besides the current working directory. Right. I already gave an example where, I created this file originally on my desktop, and then I said, I don't want to do this on my desktop. So I moved it to this documents working folder that I've been using for most of the day. And then I changed directory. So I moved my working directory to the documents folder before I did the copy command. Okay. Now I could do, so this example uses touch file 3. Okay, what do you think that's going to do? It should be creating a file called file 3 in my home directory, right? Because I've specified a path here with the tilde / that says make this new file in my home directory. Okay, so I'll hit enter, and I'll show you. I'm going to change, whoops. There's file 3. So this is in my jpdaemon home directory. So I just created that there. Now, this command right here says copy file 3 from my home directory, and then there's a space and a dot. So remember earlier, when we opened the Finder or the File Explorer from over here, right? I did like open space dot, and I said that dot, well, at least I think I meant to say that's the current directory. Maybe I didn't say that. So open dot says open the working directory that I'm in. So just like that, this cp file 3 space dot is saying copy file 3, whoops, from the home directory where I just created it into my current working directory, which right now that's in that documents folder. Okay, so if I hit enter, yeah, let's go to this. Right, that file 3 right there is going to disappear when I hit enter here. It should disappear. Oh no, it shouldn't disappear. I didn't do move, I did copy. Duh. Right. So there's a file 3 there, but now there should be a file 3 in this documents folder too. So yes, there's file 3. File 1, 2, 3. Okay. So that what I was talking about with the dot is explained right there. The dot and the dot slash. Right, that following slash, just like everything else, that Linux is seeing that dot as current working directory. Okay, and so whether or not you have the slash only matters if you want to specify something after it, after the slash. Later on, when we write our own Python programs, using that, knowing how to specify your current directory will be important, because Linux won't automatically know where to look for a new program. Like, it automatically knows how to use touch because it's a built-in command. It has a path built in to know where to go look for commands. When we write our own commands, it doesn't know where to look, and so one of the ways we can tell it is to say, hey, look in this current directory. Okay. You can try this. It's useful just to know on your system whether this is active. I have a reference to Biolinux here, which is we're not using Biolinux anymore, but it's built on Ubuntu. So Ubuntu, if you're a Windows user, it's probably the same as the Biolinux examples where I referenced that. If you're on Mac, it may act differently. So this example is saying, let's copy file question mark to, okay, so think about what's going to happen here. Remember, the question mark is going to match any character. So this is going to try to actually copy file 1, file 2, and file 3, and it's going to try to put them in my home directory. But if we go back and look, remember, in my home directory, there's already a file 3. So this is where I'm sort of testing here on my Mac. Does it give me a warning? It did not. So it can be a little dangerous. I don't remember off the top of my head how to activate those warnings. There is a parameter that you can set in your environment to do that. We can work on that in class, in person, if anybody's interested. Or, I mean, it's an easy thing to Google, I'm sure. Although you may want to wait until we talk about modifying your environment and your profile at this point. But the thing to notice here is that when I copied file 1, 2, 3, you see that in my home directory, it copied file 1 and 2, and file 3 just got overwritten. So if there was valuable stuff in that version that got overwritten, it's gone. Just like RM deletes things for good, that previous version of file 3 is just gone. So be careful. Copy-R works the same as rm-r in the sense that it just stands for recursive. There's nothing new being introduced here. Just make that directory storage. Move file question mark, right? Remember, question mark here is going to be files 1, 2, 3 into storage. Then list them. You should see all 3 of those files there. Here, copy recursively storage to storage 2. That's going to make another directory called storage 2 that has the same contents, and that recursively means copy everything in the directory. Okay, if there were multiple levels of directory, it would copy all the way down. Okay, and then I use ls. We haven't really used ls to list more than one place at a time, but for example, just whoops. Okay, so that will list my home documents folder, and this is just so you see how accidentally confusing I made it. This is going to list my documents folder because I created one underneath it. Okay, so the first thing it did was list all the stuff that's in my regular documents folder, and then it listed the documents one underneath that, which only has the things that we've been working on for the tutorial. Then try rm-r to get rid of storage 1 and storage 2. I'll let you work through that one. And then the last thing, if things don't seem to be going right, it's most often typos. And I've linked to this article, why it's so hard to catch your own typos. And this is a real psychological thing called typo blindness. It is very hard to see your own typographical mistakes. So it's really useful to have somebody else looking over your shoulder. This is part of the reason why the the class, and in-person time can be helpful, even though most of the learning is going to happen on your own in this class, especially, well, at least the programming part of it. But it can be super helpful to have somebody that can look at your code, and because it's so much easier for somebody else to see your typos than it is for you to see your own. Yeah, it's a real thing. Okay. And like I said, typos are most common, and then oftentimes it's the typos are in the command, in the path, and so Linux is looking in a place that, you know, it says file not found or something like that, and you think, well, how can it not be found? It's right there, because you can look it up in your GUI. Well, it's because you had a typo in the path. To avoid those kind of typos, use tab complete. Okay, so, and I'll encourage you, again, like I said at the very beginning, you should work on these till they become second nature. Okay, navigating the Linux environment from the command line in this way, copying, moving, deleting files, be careful with deleting files, should be as second nature as, you know, clicking and dragging in the file explorer that you're used to. Okay. All right, that's it for part 1.